everybody, and today I'm going to be looking at some GCSE mathematics upper and lower bounds. This is the EduXL GCSE Mathematics Linear 1 MAO. This is a calculator revision paper, and this is found on Mr. Bartle Maths, so you can guys go check it out. Just type in Mr. Bartle Maths in Google. So these are very helpful, and I'm going to do some worked examples with you guys. So I am going to go through this, and we'll start with the first question. The weight of a bag of potatoes is 25 kilograms, correct to the nearest kilogram. Write down the smallest possible weight of the bag of potatoes. So what you've got to do here is you've got to think about it is rounded. You got to see correct to the nearest kilogram. Okay, so it's going to be you're going to have to find something between which rounds up to that, but the lowest. So it's really hard to explain, but that's going to be 24.5 because I'm just going to do the first one like this and I'll explain to you guys why. Because it's asking for the smallest possible value, so it's got to be less than 25, okay? But because it's rounded to the nearest, correct to the nearest kilogram. We've got so 5 you would round up to 25, and that's how you would do the question. So it's a pretty simple concept, really. So that'll be 24.5 kilograms, and that is the smallest possible weight of the bag of potatoes. Okay, we'll move on to the next one now. Here we are. So we've got write down the largest possible value of the potatoes. So this is pretty much exactly the same. So the largest the bag of potatoes can be is 25.5. Okay, because if you round that up, you have to ignore. Normally, it will be like anything past that, but basically we'll be rounding up if that was a 5 anyway. So this will be 26, but it can be that because that's what we include because we've got to be halfway between both of them. So if you get what I mean, I think because if it was in the normal question, let's say we were rounding to two significant figures, 5 here we'll be looking at this and going, okay, that's gonna be 26, right? But because it's we're looking for the largest possible value of something, we are just looking at this number, and that could be 5 either way because that's halfway between 1 and 10. So that's what we gotta say. So that'll be that. That'll be 25.5 kilograms, and that'll be the largest value of for the potatoes. So I hope you got that concept. We'll do some more. The length of the line is 63 centimeters, correct to the nearest centimeter. Write down the least possible possible length of the line. So you got to think about this. It's pretty much exactly the same as the other question, but it's a different value, and then it's in centimeters. So we've got to. You guys think to yourselves. You guys can pause the video and do this question, and let's see if we get the same answer, right? So I'm going to. Obviously, this is pretty simple. You just got to write down the least possible value. So it's going to be 62.5 because that can be rounded up to 63. So it's kind of the same concept as you would there, but obviously that's that for that. And we got the same kind of question again. It's just repeated. Like write the greatest possible value, and that would be 63.5. Okay, they are pretty much the same question. I've basically just covered the same question. Okay, that is great. And now let's move on to another question. Let's hope they get a little bit harder. So a field is it's in the shape of a rectangle, right? So we've got to imagine this rectangle, and this is the field. And the length of the field is 340 to the meters to the nearest centimeter, right? So we've got 340 meters to the nearest meter, sorry. And we've got a width of 117 meters, so we've got 117 up here meters, okay? So we're going to calculate the upper bound of the perimeter of the field, okay? So there's some basic principles when timesing two bounds together. Right, I'm going to address them first, okay? To calculate the upper bound, you're going to just, actually, The upper bound is the upper bound plus the times the upper bound. Sorry. So it's just going to be the upper bound times the upper bound, because that is what we're doing here to calculate the perimeter. But actually, sorry, I've read the question a little bit wrong. It's going to be plus, as I said at the start. So it's going to be upper bound plus the upper bound, and that's going to give us that. But we're going to have to times this by 2 when we work this out, because we've got two of that and 2 of that, obviously, a four-sided shape. So this doesn't always apply, right? When we're like if you're multiplying or adding, it's the same as this. So it'll always be upper bound times upper bound if you're doing multiplication as well as addition. But in some ways, you will have a different kind of concept for looking at division and subtraction. So for subtraction, there's 2. Okay. Oh, by the way, this is the same for the lower bounds as well. If you were asked to calculate the lower bounds of this, it would just be lower bound plus lower bound, or lower bound times lower bound. But when you're doing addition or subtraction or division, it's different, because if we want to calculate the upper bound, then we're going to have to do the upper bound divided by the lower bound. Because if we were doing lower bound divided by the lower bound, it would be a very small number, right? But we've got to look at the upper bound, and we've got to divide it by the lower bound, and that will give us our answer, because that's going to be a larger number than it would have been. But we do the same concept when we're calculating the lower bound. We'll do the lower bound divided by the upper bound. All right, you've got to remember these for your exam, because bounds come up quite often, and it's not normally one of these two. Well, it could be. Don't get me wrong, but you've got to revise these. The way I remember it is upper bound times lower bound is always the one at the start. So if it's upper bound, that's always at the start of the equation, let's say, or the method. Okay, so this will always be upper bound. This will be lower bound, because that'll be at the start. I think you get me, because the lower's at the start and upper's at the start. This method applies to subtraction as well. So it'll always be upper bound subtract lower bound, and lower bound subtract upper bound. Okay, now I've addressed them. Now we can go on with the the actual question. I'm going to delete all this. Hopefully, it will all delete very quickly, because I don't want to delete the whole question. I don't know why it's not. Okay, I just go through here, and we'll delete all that. And done. Almost finished. Okay, so we've got this, and we're asked to calculate the upper bound of the perimeter. So basically, we've got to find something which is the upper bound of 117 and 340, and this is to the nearest meter. So we can put 34, 3, 4, 5, and that'll be, obviously you can go up or down whenever possible. Actually, I have done it wrong again. Sorry for this. It isn't that. It is 240.50. I think that's the upper bound. Yes, it is. So if we round that up, and we also have to do the other one, so 117.50 as well, I believe. Yeah. Yeah, that is absolutely correct. So now we would have to plus these two together. So 117.5 plus 340.5. So we would have to plus these together. So 117.5 plus 340.5 equals 458. So that'll be equal to 458, and because it's perimeter, we've only found out half of the rectangle. So what we're going to have to do is we're going to have to do 4, 5, 8 times 2, and that will give us our. Let me do this. 4, 5, 8 times 2 equals 916, and that is absolutely correct. 916. And that'll be uh, the actual question. And that was 2 marks. It probably would have taken us about 2 minutes. It is a little bit. It's about 2 minutes per mark, isn't it? About 2.5 minutes per mark, or a minute per mark, really, isn't it? Okay, so let's do another question here. We don't need to do another one of those. We'll do. Why don't we find? Here we are. Why don't we try this one? The voltage V of an electric current is given by the formula V equals IR, where I is the current in amps and R is the resistance in ohms. And given that V equals 218 correct to 3 significant figures and 12.6 correct to 3 significant figures, calculate the lower bound of I. We can do this by taking this formula, V equals IR, right? So we're timesing I against R, and we will have to rearrange the formula up here to use this. So we're going to have to divide by R, right? To get R on this side, so we can work out I. Okay, so it'll be V over R. This is basic rearranging formula. And O equals I, okay? Now you fill this in. Alright, we're going to be doing division, as I say, and we're finding the lower bound, so it's going to be LB divided by UB. Lower bound divided by the upper bound. Okay, so we've got to calculate, first of all, we've got to calculate the lower bounds of this. So the lowest bound we can have is 217.5. I believe that is correct. And the lowest one on here is 12.55. Is it? 12.55. Correct. Yes, that is absolutely correct. So now we've found V, the lower bound of V, and I have made one mistake, right? We've actually got to find the upper bound of that number because we're going to do this. So we've got to find 12.65 here, and that's our upper bound of that. So we're going to get this formula up here, and we're going to rearrange it. We're going to put them into the formula, which is 17.5 over 12.65, and that is going to give us, let's set this 217.5. You're allowed a calculator in this, by the way. This would be a calculator question. And 12.65 equals 17.193. We'll write that down here. 17.193. Okay. And we're going to do it correct to 3 significant figures like they've done here. And that's what you normally do, really. And it's going to just be 17.2, because 9 rounded. 17.2 amps, this would be. There we go. There we are. Alright. I hope you guys enjoyed the video, and I hope you guys learned something. This was calculating upper and lower bounds, and this was the EdXL GCSE Mathematics, and this was a calculator revision. Thank you guys for watching. I hope you guys learned something, and bye for now.